Okay. All right, Anthony, I like your answers. Saed and myself haven't received your answer, but that's okay. Let's go and work on this. So the type is a linear function, and again we know that because when we look at the equation, one of the term contains the x variable, and there's no exponent there. The exponent value is 1, so linear. The shape is a line, and hence we need 2 key points. The interval, Anthony, I like what you did. From left to right, we have 2 to positive infinity, but I want to check on your left boundary. Are you going to use a square bracket or parentheses? It is a bracket. We use a bracket here because of the equal condition here. All right. So now, I think I start with left. Yeah. So let me switch these places. Left first, then right. In this case, we can take the left boundary first. Why? Because we read the interval from left to right, and the first value that we're getting is 2. Moreover, that 2 is included, so this is going to be a point. Right? This is going to be a point. And what is the equation again? Negative 2x. So negative 2x plus 2. And solving this, we are going to get 2 negative 2. And we are going to use a solid dot there, right? Because positive 2 is included in this case. So that's our first point. For the second point, then we have the situation that the right boundary is an infinite. So there's no number on the right boundary there, just a mathematical expression. So what are we going to do? We are going to select a value between 2 and positive infinity, and we're going to select something that is easier, right? We're not going to put here 1 for Lilium. We are going to put here a number that is easy to work with and good number that represents that set. And that one here, for my opinion, I believe it is 3. I believe everyone should be agree that 3 is that number that we want to use. So 3, and this is going to give us, solving this with positive 3, sorry, we are going to get negative 4 for the y value. And there's it. We have our information. We have everything that we need. Again, remember that you can shorten all this by following that example of a written work. And yeah, we can go back to our coordinate plane and we can place those numbers there. So let's go here. On this occasion, you will see that the left point of the second piece overlaps with the open circle of the first piece. That's completely okay. You put it in top of there. Now we have a solid dot there. And the other one was 394. Yeah, 394. Those are the points. Again, the right boundary is positive infinity, so we need to use an arrow that indicates continuation to the right side. And that is our graph. Is this function continuous? Is it continuous? Is this function continuous? It is continuous. We are not going to enter in details of what continuous function mean, but one good rule of thumb is that if we can draw the graph without lifting our pencil from the paper, then the function is continuous. All right, so that's number one. Any question for me? Okay. So second exercise, same type of exercise. So let's see what is different and what are the challenges with this type of exercise. Okay, so green for piece number one. All right. So that's our piece well-defined function, and we need to go through all those steps. Okay, so you will help me again in this one. So piece number one, I want to focus on step number one. We want to know what is the type. I should put this here. So in step number one, what are we going to identify in step number one? Step number two, what we need, and then step number three, which are the boundaries. All right. So go to the guiding notes for unit number two, and tell me if you don't know it by memory. On the library of functions, you can identify the type of the function. What is the parent function of the one that we have here? Tell me down in the chat. It is a square function. Yes, that's correct. So we have a square function. So the shape is a parabola. And the number of key points. How many key points do we need to sketch or to draw a parabola? Anthony, check that one more time. It is 3, yes. So we want to use 3, right? Now, here is the condition. We want to see this condition as in interval notation. What is going to be that? How we should write the interval notation of the condition. I can start with our boundary numbers are going to be -4 and +4. Now, what we need to decide if we are going to use square brackets or parentheses or a combination of both. What do you think? Okay, so I have here both. What do you mean about both? Okay. Anthony, I think you're referring a combination of both. Perfect. That's what we want. There is an equal condition there, so square bracket, and the other one is strictly less than, so open parentheses. So now we can focus on our boundaries. So we have the left boundary, and let's start with that one. The left boundary, in this case, this is going to be a point because of the square bracket, because -4 is included. So y value is going to be, okay, so this is, that's the equation. There's an interesting thing happening here with this equation. So I'm going to ask you for evaluating the value for y with x equal -4. Tell me that on the chat, and then we are going over that to check, and we are going to stop here for a moment just to explain something that is going to be important for our class. So when you are ready, tell me that on the chat. Tell me the answer on the chat. All right, it is -6. And what I want to point out here is how we should interpret this exponent and this negative here. There is a difference between x squared versus parentheses x squared parentheses x closing parentheses squared, right? A common mistake is here is applying this power of 2 to the negative, and that's incorrect, because it is not explicit that these two also belong to the negative, or if this negative belongs to the x variable. So we cannot assume that, and we just need to go, the 2 only applies to the x variable, not to the negative. If we had this, that the thing is different, because now it is explicit that 2 also applies to the negative, because everything enclosed within those parentheses, 2 is the exponent of everything there. All right, so be careful with that. This is a very common mistake, and it will cause you a lot of trouble. So it's -6. So 4 raised to the power, -4 raised to the power of 2, -6, positive 16, then -16 plus 10 got -6. So we have our first point, and this one is a point. Okay, so we are going to use a solid dot there. For the right side, what we are going to use is we are going to use x equal 4, but this one is going to be location. Why? Because positive 4 is not included. So here, again, we are going to use that equation to get the y value, and when you plug in 4 into x, you get -6 again. So the location here is 4, -6. What's the problem here? The problem is that the number of key points that we need are 3. So we need to find one more point. All right. So what will be the x value that we need here in order to get that third point, that third key point for this parabola? What do you think is going to be that point or that value? So we need one more point. So that means that we need to select one more value for x. In the set of number that we are working on, we have the option to go from -4 to 4, we already used -4 and 4. Now, what number that fall into that set, into those numbers, -4 and 4, is the one that we want to use here. There is one specific number here that has two reasons why we need to choose it over every other possible value. So which of those is that number? Tell me down in the chat. What number do you want to use for x? Anthony, that's correct. The number that we want to use is 0. There's two reasons for why we want to use 0. The first one is because it's the easiest value to work with. And the second one is that, for a moment, let's just see the shape of a parabola, right? A parabola. So we can, having 3 points is what we need to draw a shape of a parabola. But this point here at the middle is the one that is called the vertex. And this one, this point is essential is the word. It is essential to be precise on the shape of this parabola, because it is located at the axisymmetry is exactly at the middle of the x value that formed this parabola, right? And it's going to tell us where to stop, right? See what happens if I just choose a third point that is not the vertex. So I start from here, but then what's happening here is unknown for me, so I cannot complete the parabola, right? And you need to use your imagination because my drawing is not the best. But see, now that in the second case, I am missing the vertex. So I do not know what's happening here. I do not know where it goes, right? I can assume, yeah, but it could be this. Well, that's not parabola, but there's not information available that we can use to know where it passed through. From here, we got that y is 10, and then we got 0 and 10. And this is a point, okay? This is a point because it's within the parentheses, the boundaries. So the left side or the left boundary is a point. The location of the right boundary is a location, and the extra point, which is the vertex, is a point. And here is where things are going to get tricky. How are we going to do that here? Okay. By hand is very easy. I know that here is my vertex. I know that here is my left boundary. And I know that here is the location of the right boundary. Perfect. That's something that I know. Right. What's the problem? When we go to Alex, so the way you plot the point using these buttons, right? So once you plot the points, you want to use this tool here, and I'm going to change the color to emphasize that one. So you want to use this. Oops. You want to use this tool. That tool, when you click there, the first you are going to see something different on the coordinate plane, so on your mouse. And the first thing that you need to do is to click on the vertex. So you are going to click here on the vertex, right? and then you need to click on either of these two. Okay. So you don't need to click on both, just in one. Remember that if we have the parabola is an even function, hence there is a y symmetry, so whatever happening on the left side is the same on the right side. Alright, so when you do this, so this is difficult for me to draw this, but no. Alright, let's focus. No, I cannot draw a parabola. All right, maybe. This is so frustrating. Okay, one more time. Okay. Whatever. No puede hacer. Okay. Okay, I'm going to try one more time. I'm sorry for this. This is not. Let me try with the right side. Maybe if I do the right side. Yes. Okay. At least that's something. And I'm just going to copy and paste. And I'm going to rotate because this is an even function. Ugh. So use your imagination. That is a parabola. So voila, a parabola. Alright, what's gonna happen here? That is what you are going to see on Alex, and that's incorrect because you are seeing that this fragment, that part of the graph, are beyond the boundaries. So that is a problem. So what are we going to do? So after you finish with the parabola tool or function, I don't know, you need to erase those two parts. I'm going to highlight those parts. Okay, we need to cancel those. Then what you're going to do is to use the scissor tool. All right. When you click there, now you can click on top of the graph. When you click on top of the graph and you want to click here on the boundaries, you will see like a cross on those clicks. That means a cross there is very tiny. That's another thing that you need to check. Those cross represent the point where the graph was cut off. So when you see those cross after using the scissor tool, that means that now you have three pieces for this parabola. This piece, this one that is the one that we want, and the third one. All right. Then what you are going to do is you are going to click on the eraser button and click on top of this fragment, and you will see that this part that is highlighted here will disappear, and you will do the same for the right side. All right, both highlighted part are going to disappear. All right, and this part will stay because they are not attached together. All right, if you don't use the scissor tool first, when you erase one part, you are going to erase everything because they are attached together. You need to use the scissor tool first in order to separate the parts of the graph. Is that clear? Any question on that? All right. So let me show you how it looks like. Right. So the second part is how you say that? The second piece is a line, okay? So you need to basically repeat the same process as we did. And then here, what we have is the final solution. So that's how you will see the graph, or at least that's a representation of the graph. Okay. Any question? All right. Okay, these two exercises, this is the same. We need to graph that. We need to draw the graph of that function. This one is interesting. It is very easy to do, but if you are doing this the first time, it might confuse you. I'm not going to do it here, but just keep in mind that you're going to see this type of function, this type of piecewise defined function, and it is tricky to get it. But once you understand everything about it, it's going to be very easy. This is just for evaluation of the piecewise defined function. So what you want to do here is to use the x value that is given there. So the x value is given here as an input, right? So you need to find the y value. What is the y value when x is negative 2? So you're going to take negative 2 and you will see on which of these conditions negative 2 fall in. And based on that is the rule that you are going to use, or the equation that you're going to use. The last exercise is one that I want to talk about because it might cause confusions. All right, so we need to find the domain and range of this graph. And we need to remember that a domain is for the x values and range is for the y values. And let's start with the domains. The domain. So domain, you focus on the x-axis, and we read the graph from left to right, from left to right. The first point that we are seeing is here, right? So here you have, that's the x value of that point, negative 3. All right, continuing reading the graph, we notice that it ends here at negative 2. So this graph elongated, but horizontally it runs from negative 3 to negative 2. So this interval is from negative 2 to negative, from negative 3, sorry, to negative 2. And if we want to describe that interval, we need to use closed or square brackets because we have solid dot here. Then you can see a gap, or jump in the graph. And now it starts at 1, and negative 1, with an open circle. It continues, the graph continues until positive 2, right? So now the domain travels from negative 1 to positive 2, all right? Negative 1 with parentheses because it is an open circle, and 2 with square bracket. So that's the domain. The domain now, it has two parts, two interval notation, two sets. And the way we connect those is with the letter U as for union. Okay, so that's the domain. Now let's focus on the range. If I can move this properly, yeah, okay. Thank you. Come on. All right. So that's the domain. Now let's focus on the range. The weird thing here for the range is that we are used to read from left to right, right? So we are not used to read from the bottom to the top, and that is what we need to do here. We need to read from the bottom to the top. Okay, starting from the bottom. Now we're here. We have -4 here, right? Then continue up and we have +5 here. Okay. So the graph goes from -4 to +5. This elongated part, this first fragment of the graph, the range of that fragment also covered the range of this fragment. So we do not need, having a second fragment here might confuse you about the range, but the range goes from -4 to 5, also using square bracket because solid dots. Okay, so this might confuse you in terms of the range, but you just look at the y-axis and you see that all this is covered by the first fragment. So from -4 to +5 with both square brackets, and that way you answer this. And that's it for today. That's all the exercises that I brought for our class today. Is there any question?
I have a question. I emailed you last night and you responded about meeting. Could we do that now since class is done?
Yeah, that's what we're going to do now. Yeah. All right, Syed, is there any question regarding unit number 3? All right. Well, thank you for being here. Thank you for participating on the class. I wish you, today's Wednesday, right? Well, I'm going to see you on Monday. I wish you a great rest of the day and great rest of the week. So, bye, Syed. You can leave if you want now. All right. You're welcome.